All right, you've made it to the second day. Azure Service Bus.NET Standard, show must go on. So there will be a few stories from the trenches in this session. But before, short introduction. I come from Canada, a province called Alberta, a city known by the name Calgary. Not many familiar with the city. Usually people know it as the airport on their way to the Rocky Mountains. That's where I live. Now, what do? I work for a company called Particular Software. People might be familiar with the product that we sell, NET Service Bus. What we do is we help our customers create reliable distributed systems using messaging. And Azure Service Bus is one of the transports that we utilize when helping our customers. I'm an Azure MVP and Azure Service Bus.NET Standard Client Contributor / collaborator in my free spare time. So before we get into the contents of the session, I want to start with a question. What was significant in 2016? A lot of things, I agree. But if we're talking about messaging and Azure Service Bus and .NET, what was unique about that year? That's okay, there were many things. Nowadays, every day is a unique day. .NET Core 1.0. That's what happened to the .NET ecosystem. And Azure Service Bus is not an island. It had to respond to that as well. But that change was very different. This is where I want to present in this session and talk about the changes and decisions that were made, how it affected the client, and what are the good things that we can expect in the future or already. So first of all, if you were a .NET developer using Azure Service Bus, you were probably looking at a package called Windows Azure.Service Bus. And by the way, who's in the audience used Azure Service Bus? Significant number, very nice number. So you most likely have seen this package and used it, starting back from 2011, when Service Bus has been introduced and G8. The only challenge with this package, it could not make it into the brand new world of .NET Core. So the product team had to decide what to do about it. And the decision was very simple. It's just not going to make it there. The natural and also very painful decision is to rewrite the product. Well, not the Azure Service Bus backend, but the client, right? And the rewrites are usually very painful. What do? Do you rewrite the whole thing and publish it? Do you start feature by feature and confront the customers that want to do everything that they were capable of doing before, right? Is it even possible to rewrite given the new .NET Core world and .NET Standard? Because you still need to target the customers on .NET Framework, right? Multiple questions. But why rewrite actually was needed? What was required? Well, to answer that question, it was only targeting the .NET Framework, obviously. It had two competing protocols within the same client. It was SBMP or NET messaging. And SBMP stands for Service Bus Messaging Protocol, a proprietary protocol, which was not as standard in the industry. And AMQP that was added later, supporting both in the same client. Well, you know how it works in your products, right? It's not very trivial and easy. Have you tried to reflect that code? It was closed source. So if you wanted to look at what's happening, if there is a bug, understand how it's working, it was pretty much impossible. Part of that because it was using the APM style of async programming, all the begin invoke and invoke async result, right? Reflect that and good luck. And not to mention the fact that there were enough skeletons in that code base that the team didn't want to continue. And if you don't believe about skeletons, well, ask the project manager. He will tell you. So obviously when you facing this question of rewrite, one of the questions that is also rising. Should the client be open source or not? Prior to that, it wasn't. The old client was not open source. Should the new client be open sourced? What are the drawbacks? What are the benefits? What are the options? Well, the closed source model was a bit brutal. Anyone who wanted to debug what's happening with that client was not able. Basically a black box. When it comes to the open source, well, there are several models, right, that you can apply. One of them is maintainers hold the keys. No one else can make any decisions, nothing else. No contributions are accepted. It's open source, but you can't really do anything. Open for PRs, closed for any design decisions. That's also a model, right? Pay to play, which is becoming more popular nowadays because everyone understands that open source doesn't necessarily mean for free. If you want to do something, you need to contribute back. And sometimes contributions can be financial contributions. For example, you want your PR to be looked at or your issue to be resolved, pay for support. Now, obviously, Azure Service Bus product team would not go that route because the client is not where they make the money. It's the Azure Service Bus itself, utilization of the service. So what are the options, right? All these kind of questions the team had to answer. So what was different this time? A lot. First of all, when answering the question, Microsoft had a new reality laid out, right? Microsoft loves open source. So it was very easy for the product team to accept the fact that the client will be open source. Not to mention that GitHub was more acceptable than any time before, right? So it made natural sense to move the client code into GitHub and use that ecosystem to interact with developers. And looking at this slogan today, it's actually funny because it's the same as saying Microsoft loves Microsoft. So there's no problem. So with all that love in the air, there were changes coming. Lots of changes. Let's talk about those. Quick timeline, right? The new library was not built in a day. Don't get me wrong. It took several years. 2016, a new client repository was created. Later that year, a preview was released, right, with very basic operations. So if you were on .NET Core and you wanted to use that client, you couldn't do everything you were doing the old client on full framework. Just send, simple send, receive, right? 2017, it RTM'd. 1.0 was released, shipped, with support for open-close principle, which is very fundamental change. In the past, if you had a client, you couldn't do anything other than utilizing the client. With the extensibility API, which we'll cover a bit later, you could actually customize the way Azure Service Bus client was working. And that's substantial. Later that year, 2.0 was released. And accidentally, it was supporting NET Standard 2.0. This is where things picked up a little bit more. As you remember, NET Standard 2.0 came with pretty much all the APIs that you needed to perform things like transactions or transaction scopes. Early 2018, 3.0 was shipped with transactions and send via features. At this point, the client was almost at feature parity with the old client. Almost. What was missing was released later in August, and that was management operations, which was very interesting interaction with the community. And I'll cover that part as well. And then there was December 2018 release, 3.2.1, which was significant not because it was inverted 1, 2, 3, but for a different reason. And I'll cover that. So let's talk about those changes and look at more details. Protocol-wise, SBMP was declared as dead, which is fantastic because it was replaced entirely with AMQP. Right? This is AMQP 1.0, which could also support or was supported over WebSockets, just in case TCP ports are blocked. But don't get mixed up. This AMQP has nothing to do with AMQP 0.9. Completely two different things. The new client was 100% asynchronous. And this is very important. The reason why it's so important is because the whole client is built around I/O operations, about networking. If you have anything to do with I/O, it has to be async, right? And the difference this time is that the client was not based on the APM library, it was based on async await, ground up. And by the way, if you had to rewrite any code that has to do anything with async, you probably notice that it propagates throughout your base code, or if you're creating libraries. The second change, it did not contain, or it does not contain any synchronous APIs. Very simple. If you're doing I/O, it should be asynchronous. The next significant change was the brokered message, the canonical brokered message, right? The payload that is getting transferred between senders and receivers. Brokered message was gone and replaced with a simpler construct that is representing message, called message. Along with that, the client was no longer performing serialization and deserialization of the messages, right? This is basically saying you can come with any payload as long as that payload is byte array. And it's your concern as a user to perform serialization, deserialization. And that's actually a good change because it took one responsibility out of the client, right? Following the single responsibility principle. Use serialization, whatever you want. The client is not going to do it for you. Separation of the properties, right? The property bag that was on the brokered message got split into two, user properties versus system properties. Also, as I said, message became solely data, which means the operations were gone. Well, they were not gone completely, they were just moved to the appropriate classes rather than being performed on the brokered message itself. Again, single responsibility. Now, there was one change that is a bit painful, and that's broken wire compatibility. And when I say broken wire compatibility, I'm talking about messages that were sent using old client versus received or sent with the new client, right? Because when you upgrade your systems, there is a chance that there is a message in flight that is going to arrive, and it's not necessarily compatible. Now, the new client is providing an extension method called getBody of type T, which solves the problem. The issue, though, is that you have to know the source of the message, where it's coming from, in order to apply this extension method. A workaround is probably to go and update the legacy products or projects or older processes that are running with the previous version of the client to either stamp the message or somehow indicate where the message is coming from to be able to process it. But again, it's a change that is required, and moving forward, if you have addressed it once, you don't need to do it anymore. So let's look at the wire compatibility issue, just to give you an idea what it looks like. Folks at the back, can you see the code? Yep, good. So in this code, we're going to have two clients, the old client and the new client. The old client is going to send a message, a simple string, right? We're going to send it as a string, and what's happening behind the scenes is the old client is performing serialization, where the new client is going to receive the message, and all it knows is a body, which is a byte array, and it's going to dump that byte array, right? Converting it to a string. Running the sample, zoom in a little bit. Yeah, the queues don't exist. Here we go. This is what we received. But instead of the string that we expected to get, we got something a bit more. So that's the problem with the serialization. The message arrived serialized, where we just got the raw byte array and converted to string. That doesn't work. What's the solution? Well, the solution is to use that extension method, right? Rather than getting raw byte array and converting to a string, we're going to go through get body extension method, saying, hey, that message was serialized. I need to deserialize it, and it's a string. So rerunning the same code should yield us a proper result, the string that we expect. Right? And that's what we got. Let's go back to our presentation. Now, the operations that were gone from the brokered message itself, the operations that are not on the message type, those were all moved into clients and specific objects or specific type classes that are responsible for sending and receiving operations. In this case, we're talking about the first group, the clients, the queue, the topic, the subscriptions, all the possible entities on Azure Service Bus that you can interact with, and message sender, message receiver, more lower end implementations. Now, just to make sense out of that, the first group is implementing an abstraction, right, that is needed in probably 99% of the use cases. I have a message I need to send it, or an event I need to publish it, and I need to receive messages in a very simple way. And a simple way is a message pump, basically a mechanism that it's constantly receiving messages and providing those messages to your code. And your code is usually registered with a callback, so whenever a message is coming in, the user callback is invoked with that message. The second group, the message sender and sender receiver, message sender, message receiver, are more for advanced scenarios. So for example, when a standard message pump is not something that you like, either it's the concurrency model that you're not satisfied with, or the implementation details need to change and whatnot. Maybe you need to receive not message at a time, but a batch, right? And you want still a pump. In these cases, you would utilize sender and receiver to build your own message pump. Now, talking about message pump, there were certain improvements introduced in the new client as well. For example, the old client, just like the new client, had the ability to register the callback or message handler and receive exception details. The only problem is that if you were running, for example, against working against two namespaces and there was an exception, you had no idea on what namespaces the failure occurred, right? One of the examples. So that was fixed in the new client. Now you know the endpoint, which is the namespace, and you know the entity that has failed. So if you're running more than a single pump in your code because you receive messages from more than a single entity, you will know on which entity that exception occurred. And that's extremely helpful when you troubleshoot anything that is related to messaging. In addition to that, the name of the operation that failed is now passed in, meaning that it's not just the namespace and the entity that you had issue with, it's also what type of operation has failed. So for example, if you are in a callback, a user callback message handler, right, it's not enough sometimes to just get the exception itself. Sometimes you really want to know which operation that failed. For example, extending lock, right? Is that the one that is failing, or the receiving operation? Because based on exception, you might take one action or another. A client affinity, that's another change that happened with the library. Receive complete or send receive operations in the past could be done by different clients. With the new client, it has to be the same object. And I'll demo this to explain better what I mean by that. So let's look at the old client code. The old client was creating sender and two receivers, receiver 1, receiver 2. The message was received using the first receiver, but the completion of the message was done with the second receiver, right? With the new client, I'm going to attempt exactly the same thing. I'm going to create sender and two receivers, right? Receiving message using the first one, and then completing using the second receiver. Almost identical code, except the results are different. Right, the old client is executing, message is received, the new client is executing, and we get an exception. Message log lost exception. Wait a second. How did we lose log on that message? We haven't really even processed the message. So the exception is a bit misleading, but what happens is very simple. The new client is implementing AMQP, where the old client by default was SBMP, or NET messaging. With the old client, there was a little bit of black magic happening. When you were creating those receivers, you could receive using one and complete using another receiver. With the new Azure Service Bus client, the receiver that gets the message is the one that has to complete, because the AMQP link that is established has to be exactly the same link to complete the message. Otherwise, it's considered to be a completely different link, and message doesn't have the lock. Sorry, message is not locked. Okay? So why this is important? It's important if you're moving off the old client, right, and you had multiple receivers that were able to complete any messages. If you're now using the new client, you have to really stick to the same receiver. All right. Next change. If you notice in the code, the new client has no factories. Is that anti-pattern nowadays? No, it's not. Don't panic. Factory is still a valid pattern. It's just it was a very confusing pattern in Azure Service Bus. Right? If you wanted to get a message sender or message receiver, you had to go through factory, which means the responsibility for certain things was hidden from the users, which leads to the connection management. No one actually realized it, but factories were used to perform connection pooling. So whenever a factory was giving you a message sender or a message receiver, it was reusing the same connection behind the scenes. And it was very confusing because de facto factory was a connection. So in the new client, that was addressed, right? By introducing an explicit concept of service bus connection. And if you want to reuse the same connection for senders and receivers, or any client actually, you would pass in that service bus connection object. And if you want a brand new connection, just pass connection string, right? And it's also much easier from the user's perspective to manage that code because you own the lifetime of that object that you created. And you make the decision whether it's going to be pulled or not. And by the way, creating connections, brand new connections, is quite expensive. So it's much easier to create the connection and share it with multiple objects. Let's look at the connections demo real quick. So what we're going to do is I'm going to use a connection string, right, and create message sender and message receiver passing in connection string. AMQP implementation by default is using a specific port, 5671. So I expect to see two connections open, two concurrent connections. Okay, we're not going to close the clients just to make sure that we can find the port utilization. So let me zoom in a little bit. Okay, here we go. So user query, that's our script that is running, has two connections, two concurrent active connections, right? They're not grayed out. So what happens if I want to reuse the same connection? Like I said, we are going to, let me, this code. What we're going to do is we're going to create that connection object and reuse it. So creating the connection, right, and passing it in. Let's rerun the code again. And, oops, sorry. Look at the resource monitor. Still showing me two active connections. To address that, just cancel and reset to make sure that we're killing previous connections in case they were not closed, and rerun it. All right, so you can see the grayed out 5671. This is what we had previously, and only one connection that is active. So a single connection shared by both sender and receiver. Let's go back to our demo. The next significant change, the namespace manager. Now, namespace manager was a class used in the old client to perform all the management operations, creating queues, querying for topics, subscriptions, etc. And the decision was made to abandon this class in favor of management operations general library that was available for all the resources. The only problem, it was not using a standard connection string. It required Active Directory credentials or certain parameters that you needed to pass, in addition to already existing connection string. So, as you can imagine, there was a little bit of pushback from the community, and it pretty much can be described this way. The customers didn't want to use that management library at all. The lesson learned from this experience is don't piss off your customers. If you provide something for years and years and it's working and it's a good model for them, be careful by just deprecating it completely and throwing a brand new thing, right? This was an attempt. It was also a very good example of community pushing back, right? I believe there were about 93 comments, probably the most commented Azure Service Bus issue so far. It's probably nothing comparing to .NET Core issues, where threads are going on and on and on. But for such a small library, it is a significant amount. It took 3 major releases to actually convince the team to do the right thing and bring Namespace Manager. Now, they didn't bring Namespace Manager as is, as a static class. That thing is gone as well. They introduced a management client, which again, you create and you manage the lifecycle. And as of today, by the way, 3.3.0 was released, which also allows you to query the namespace type or namespace information, giving you the SKU and tier information. And why is it so significant? It's because you have 2 major tiers on Azure Service Bus, the standard and the premium, right? And there are certain subtle differences between the two. For example, maximum message size. So today in the code, in order to determine what's the maximum message size, you have to provide that information, which is already available on the broker, right? So as of 3.3.0, as of today, you don't have to do that, which is great. Now, don't worry, my computer is not crashing. I already did this about half an hour ago. Exceptions or exception handling with a client. A couple of issues in the old one. The base class was messaging exception. That's not intuitive. There's all types of messaging that can happen. Messaging entity not found wasn't really helpful. And you know why? It didn't actually tell you which entity was not found. System timeout exception was used to represent timeouts. The problem is that this was a BCL type, which doesn't have the concept of transient exception. And transient exception, the idea behind that is if Azure Service Bus broker is throwing transient exception, that means you as a client should retry, and you most likely will be successful. Now, system timeout exception doesn't have that concept. Right? A bit funny. So better exception handling in the new client means better base class. Service bus exception. Now this makes more sense as opposed to just, messaging exception. Is transient property introduced on all the exceptions to indicate whatever the operation should be retried in order to resolve the failure. The service bus timeout exception is a type on its own, no longer system timeout exception class is reused, which is fantastic. And messaging entity not found is finally telling you which entity is not found so that you can log it and troubleshoot. Another change that took place is retry baked into the client, right? Now, there is no option to inject your own retries, but you can either leverage the sensible configuration that by default is enabled, or you can reconfigure retry policy, right? Back off number of times to execute, etc. Now, there is one gotcha. You cannot use the retry policy with the operations that are included within a transaction scope or within a transaction. And the reason for that is because due to some design limitations, I'll put it this way, if you run it within a transaction and you retry the operation, that operation will be re-enrolled into the transaction multiple times, which is not a good thing, right? So transactions, if you run it within the transaction, retries are disabled and you have to implement your own. The MSI support is there, or Managed Service Identity, which is a fantastic feature because it actually allows you to cut out the connection string from your code, right? So if you run it on Azure VM or Azure App Service, if MSI is enabled, your application can talk to the service bus, right? And it will be authenticated automatically. And yesterday we learned that we need to keep it secure, the hobbits. Another significant change for the client was adoption of semantic versioning. And that was big because it follows that strict model of major, minor, patch, right? You know for sure that there will be no breaking changes in minor patch, period. You can introduce certain changes that are non-breaking in the minor version, right? And you know that anything that you release in patch is backwards compatible. No surprises. Now, you clearly indicate version, for example, with major, you know for sure that not only there are probably bug fixes and new features, but those might not necessarily be consistent with the previous version, i.e. you have to retest and there will be changes or breaking changes. The other thing is public API validation. And that was significant, right? I mean, I don't know how many of you creating libraries for other projects or customers, but it's actually a very serious business because every single change that you're making to the code can impact production. Every single PR, public API is validated, right? Every release, public API is validated. And it's completely and fully automated. And the way it works is very simple. Whenever public API is created at a certain point in time, a snapshot is created, right, and committed into the repository. The next time there are changes, the same public API is rebuilt, and the snapshot is created to compare with the previous one. And there are any differences, right, the test fails, basically indicating, hey, look, you have changed public API. And that prevents any breaking of the semantic versioning, and also enforces you to think about, okay, what this change should be. Should it be a patch? Should it be a minor? Should it be a breaking release? Right? All of that. Now let's look at how it actually works. We're going to open up the Microsoft Azure Service Bus client, right? And there is one class which looks like a unit test. That all it does, it takes the assembly, the client assembly, creates the public API, and runs approvals. All right, so if I'm going to run that approval, no, not on this one. I'm going to run it on NET Standard. So right now, everything is dandy. Now imagine us accidentally going into the message class, right? And let's say at a certain point in time, there was a decision made that we need some property. And we're just going to add that property. Of type string, I'm going to call it some property. Everything is great, it's compiling, fantastic, I'm using it throughout the code, and I'm going to commit this. How do I know that I'm not breaking any APIs? Well, API approval. What I'm going to do is I'm going to re-execute it, or it will happen automatically on the build server. And what will happen is that the previously approved API is going to be different from the currently appearing API. And it will fail telling us, hey, look, we're expected one thing, but we found something completely else. There is some prop. So now we're forced as developers, right? Or in this case, Azure Service Bus team, they're forced to look at the change. Let's say it's coming as a PR from the community. And say, oh, wait a second, we're introducing a brand new field. Okay, that needs to be a minor release. But if I'm changing, for example, an existing method signature, that's a breaking change. That will have to be a major release. So you know what? It's not going to go in the next release. It will have to hold off for the next release. Now, testing-wise, automated testing of the client, right? It's running on every commit for every pull request, including community pull requests. It's running on the app layer, right, for each PR. And one of the challenges was, what do we do with the pull requests coming from the community, right? I mean, you have connection strings. In this case, there is a connection string. We don't want to expose that connection string because, well, anyone can commit a unit test that grabs that connection string, sends, somewhere, and then, hey, it's a party. So the answer was, we're going to secure a connection string. And the way it can be done is using ARM templates. Every time build server is spinning up a build, a brand new namespace is created using an ARM template that is checked into the repository. And at the end of the build, that namespace is destroyed. Right? Simple and very clean and secure. And there is actually a button to provision that ARM template into your subscription, right? To have your own testing namespace if you do some contribution to the client on your own time. Another significant change that took place in the new client is source link support. And it might sound like a very niche feature, but it's actually a very handy feature. The idea behind source link is to be able to step into the code of the library that you're using. So in this case, what you see on the screen is the Azure Service Bus library, right? It has the DLL in the NuGet package, as well as the PDB file. And what happens with that is that you no longer need to have the debug symbols, the PDB file on a symbol server, right? It's embedded within NuGet package. It allows ASB client code to be debugged within your projects, within user project. You literally can step in, right? Also helps to identify issues with the code, because sometimes it's not the user code. Sometimes it's actually the library that you're utilizing has a bug. And to be able to identify it, it's really helpful to be able to step in and see what's happening. Another change that took place in the new client is extensibility API. A little trivia. Who knows where this is coming from? Exactly. vStock server. So that extensibility, a somewhat similar concept of that extensibility, was recreated in Service Bus pipelines. Right? Outgoing pipeline to execute plugins or certain add-ins before message is sent out, and the incoming pipeline, right, after message is received and before it's handed to the user code to execute certain pipeline. The plugin architecture is extremely simple for those pipelines. There is an abstraction baked into the client, which is called Service Bus plugin, right? Abstract class that you have to implement. You have to provide a name for the plugin because that's how plugins are registered. There is an optional property, should continue on exception. In other words, should the plugin fail the whole thing and bubble up the exception if there is one taking place within the plugin, or should it just swallow it and continue? And then two messages before message send, two methods, sorry, before message send and after message send. That's where you basically implement the logic of the plugin itself. And since release of the client, there are quite a few plugins that are now available. The first one was Message ID. And it sounds funky. Why would you have a plugin for a Message ID, right? Like, what's the logic? Any ideas? People that used Azure Service Bus? Message ID, what's significant about it? I'll help you. Deduplication. Normally, when you create a message with Azure Service Bus, a random message ID is assigned. Usually it's a GUID, right? The problem with that approach is that if your system prone to create duplicates, there's no way to deduplicate those messages because deduplication on Azure Service Bus works by looking at the message ID. And if within the time window that message ID was seen previously, right, message will be deduplicated. If your system creates messages every time with a new GUID, that's not going to work. So what you can do with the message ID plugin is you can plug in your logic saying, you know what, I'm going to take the body of the message, for example, compute the hash, and assign that as the message ID. So if I receive the same payload more than once, it's going to result in the same message ID, which will be deduplicated on the broker. Right? That's just one example. The way it works is extremely simple. You register the plugin, right? You create the plugin. Here's a simple implementation. Again, very naive implementation. I'm just creating a GUID in a certain format. You register the plugin, and off you go sending your messages. The next one is Service Bus Attachment Plugin. So before we start looking at the code, the idea behind this is very simple. Let's say you were using MSMQ, and you were used to messages of 4 megabytes, right? Up to 4 megabytes. Now suddenly, you're more restricted when you're using Azure Service Bus because you can use either 256K or 1 meg, if it's a premium tier. So if previously you were sending larger messages, now you can't really do it. What do you do? Well, one option is to keep your message, right, the body, the payload, somewhere and send just the reference to that location. Let's say it's a blob. But it's not really convenient because now you're forcing the receiving party to actually do the rehydration of the message, go to the blob, right, read the blob, consolidate all together. What Service Bus Attachment Plugin is doing, it's doing it for you automatically by implementing the claim check pattern, right? And for sender and receiver, it's pretty much seamless. A message is going out and message is coming in with whatever size of the message. And again, it's fairly straightforward. The API is slightly different. It has an extension method rather than going and saying sender register plugin. It just register attachment plugin with a configuration. And the reason why there is a configuration is because you can specify various options. Either you're using, in this case for storage account, a connection string with shared key, or container SaaS or service SaaS, right? That's where you need configuration. But again, you have your message with a large payload, you send it, and the receiver registers the plugin and just receives it. That's it. Service Bus Compression, another plugin. The idea here is slightly different. You still have maybe large messages, maybe not, but you are in a constrained environment where sending large messages is expensive. For example, I don't know, remote location or a ship in the ocean, right? So you want to compact that message as much as possible. So rather than sending raw bytes, you can compress them and then send. And the same idea is here. The sender is not aware of the details. The receiver is not aware of the details, how to decompress. All they know is the compression plugin needs to be used and what's the compression method, right? And here's again a little bit of the code, right? Register compression plugin, by default it does gzip, provided by .NET. And sender is sending the message, receiver also registers the plugin, does receive, gets the message, everything works great. Now what happens if you have multiple senders and they use different compression methods? You can just add additional decompression methods to your receiver. It also allows you to transition from one version of compression to another version if needs to be. Another one, login plugin. The idea behind this, also contributed by one of the community members, is you just want to create a copy of the message that is going out, right? And in this example, you can decide whatever it should bubble up the exception or not if that login operation is failing. And what we're going to do is we're going to look at a very simple implementation of Service Bus mischief, right? Or what is it? Going to look in a second. And by the way, all of the plugins are curated by the team at this repository. I'm going to share my slides so that you can find the URL. So let's look at building a very simple plugin. The idea behind this plugin is I want to test my code using Azure Service Bus, but I have certain edge cases. For example, I want to test the code, my code, when I get server busy exception or timeout exception. Now, the problem with these types of exceptions is that they're not deterministic. I don't control them. In other words, I cannot say, hey, now the broker will raise that exception. What do I need to do? Well, either I need to use, I don't know, overwhelm the broker, right, to start throttling my connection, or something else funky. I don't want to do funky. I want to do something very simple and very deterministic. So what I'm going to do is I'm going to create a plugin, right? A very simple plugin. The only mandatory thing is the name of that plugin. And we're going to say name of whatever the plugin is. I'm going to call it mischief plugin. That's all you need to get started. This is a no-op plugin at this point. It doesn't do anything. And the test that I will create is the following test. Let me just pin a few things here. Right? Grabbing a connection string to my namespace, creating a sender, creating a message, and I want to send a message and see that it's throwing server busy exception. Okay, running that test. I can run it once, I can run it twice, I can run it as many times as you want. Is it going to pass? Yes? No? It's going to fail. If I rerun it again, will it pass? Who says yes? Who says no? Okay. What if I'm going to run it 100 times? Will it pass? Will it fail? You get it. Exactly. It's not non-deterministic. We can't really know. So what I need to do is I want to be able to say, you know what, for this message, when I'm going to send it, make sure that it's failing. Okay? So I'm not going to type it in all right now. I'm just going to cheat a little bit. But I'll go over the implementation with you. So the name of the plugin, right? Should continue on exceptions? No. Bubble it up. And then we're going to do before message send. That's the only method I'm interested in, right? I'm going to do some really naive implementation here. I'm going to say, you know what? Every message that is sent out, I'm going to expect a user property called exception to throw. If I don't find one, I'll pass the message on to the pipeline, to the next plugin or whatever, or to the client to send it out. But if I do find this property with a value, I'm going to take that out and create, yeah, this is really bad code. Don't do that in production. That's a typical stamp on any sample, I guess. I'm going to take that exception, turn it into server busy exception, and raise it. Now, obviously, a more proper implementation would not hard code to server busy exception. It would accept other exceptions or other types that we can throw. So now going to this plugin, test of this plugin, I need to utilize it, right? What are the changes that I need? Well, it's a plugin. I need to create it. Let's create that instance, right? And I'm going to just register it with the sender. So sender, register plugin, our plugin. So at this point, it's registered. Do I need to do anything else? Yes, you're awake. That's good. We need the property, right? So we'll say message.user properties and the name of the property. equals to, well, it expects to have server busy exception. Okay, so now what will happen is the following. The message will be sent out, right? It will go to the client. The client will execute registered plugins. One of the plugins is our Mischief plugin, which will look at the message, see that, oh, I need to throw this exception. It will not attempt to send the message out. It will actually throw the exception, and therefore I can, pass my test or be able to test the components that are using Azure Service Bus Client without necessarily trying to get to that exception in the real world. So let's rerun the test. And it should be green. Fantastic. So you just build your own first Azure Service Bus plugin. You can imagine the opportunities that it provides. So what's next? Well, there's still work to be done. The client is not finished yet, right? There's about 68, 70 open issues. For example, sending cancellation token into the receive operations. It's not supported today, but it's something that definitely could be. Safe batching as a feature, for example. It did not exist in the old client, but it could exist in the new one, right? The idea behind safe batching is that when you have several messages to send out, today there is no safe way to do so. What happens is that you send the batch, and if the batch is exceeding maximum size, upon the send operation, exception will be thrown, which is not the best way. It is much better to do something that Event Hubs, for example, is doing. When you build up a batch to a certain point where the batch tells you, oh, sorry, I cannot accept more messages. And once you have that batch, you send it out, and you know that it will be passing the maximum size limitation. There are 4 issues, the last time I checked, 4 issues that are actually explicitly labeled with help wanted, which means community members can start contributing, right? What that means is that it's not just, hey, you can do this work. It means we also answer the questions and help you, guide you somewhat to do this implementation. You're not on your own. Another big thing that is probably going to happen to this client, as other clients, is the support for better memory utilization, utilizing span T and memory T, right? Because there's a lot of byte arrays going through. And also, it's a great opportunity to help other client libraries on Azure, right? It doesn't have to be just Azure Service Bus that is shining. There are many other clients that can shine as well. And for the final notes, it was just about 2 years of transformation, but they were enormous. You could see the timeline and the fact that features were not added all at the same time, but natural progression. And if you talk to the team, you will actually find out that their current policy is a very reality-safe policy. It's adding features that are really needed. Because if you ask your customers, what do you want? They want everything. That same moment. But if you assign sort of price tag, right, and you say, well, I can only work on 1 or 2, which ones are more important? Go vote on GitHub. You will see what features really matter, right? And if there are customers that certain features are really important to them, they might actually contribute those as well. Right? So for example, if you're working with Azure Service Bus and you need a specific feature, you can open pull request. It's possible now. Now another interesting fact, 23 contributors in total, 8 are Microsoft employees. And that's an interesting trend. So technically there are more collaborators, right, in the community than Microsoft employees that contribute to the code. Not necessarily true, the contributions might be small, but still, the fact that there is involvement is significant. The iterative development also removed the big design upfront of features that no one will be using. Anyone remembers the feature of the old client maybe, with 2 namespaces, fallback namespace? No? No one remembers that. Why is that? Because it was not really well designed. It was not really something that the customers were using, right? But it was there. The customization of the client is very interesting because it's the OCP principle right there, right? The client is kind of closed, but it's open for certain modifications that are required. So you might be able to send a PR for certain things that you require, but you might be able just to create your own plugin, right? And be done with that. So going back to the beginning of the presentation, I mentioned the release 3.2.1, right? And the significance of that one. The significance was that a community member released a version of the plugin. So it sounds interesting. It's not entirely that community member was able to release. It's the community member that was able to build the release, bring the release to the point where Microsoft just had to push the button to make it public. And that's not the Microsoft that we've seen several years ago, right? So I hope you enjoyed it. Any questions? I'll be happy to answer. Now, I realize that I'm a man standing between you and your lunch. So if you want to go to the food, I'll be around and I'll be answering questions between the breaks and at any point in time. Thank you so much.